everyone. What I'm going to do is share with you today a video regarding the conceptual understanding of fractions. And before I continue, for those of you who don't know me, I'm Darlene. I've written and published the Math for Success kindergarten through grade 6 teacher guidebooks, and have developed and created a lot of other products, and just am passionate about helping out and how we teach mathematics for the benefit of our students. And if you want to find out a little bit more, you can visit my website at www.mathforsuccess.org. Anyways, back to this video. I'm going to share with you a little bit about the conceptual understanding of fractions. About 3 years ago, I read this unbelievable article in the Teaching Children's Mathematics magazines, and I want to say yes, it was in October of 2015. And I read this article, Iteration, Unit Fraction Knowledge, and the French Fry Tasks. And I was just absolutely fascinated on how we taught children fractions. And what we did is we used to, and I know how I even learned, is that there were whole parts, and we taught them that there were shaded and unshaded parts. And this kind of understanding, this kind of learning initially, really, there are misconceptions of teaching unit fractions as one out of something, or these shaded versus unshaded parts. And I know that is very true, because when I went to go teach and mentor in a grade 5 and 6 classroom, and I asked them what fractions were, well, out of 24, they were just struggling, and all I got from one boy finally was that the number of shaded parts out of the number of unshaded parts. They didn't have that conceptual understanding that it is a unit. It is a unit out of a whole that repeats itself or iterates itself that many times. So some of you might be going, I'm not sure what she's talking about. So I'm just going to share with you just a little bit about that. And this is how I went about teaching my grade 3 students that conceptual understanding of unit fractions, following the information within this article, which I found absolutely fascinating. And what I did was I just took strips of paper, and this strip of paper was considered to be the whole. And some of you might be thinking of the bar model, but the idea is they had to take this whole, and it could be a French fry, and they had to share it with a certain number of people. And what we can do is start with little guys, different kinds of objects, right? Different sizes of objects, and they can iterate this object however many times they need to, no overlaps, to see how many of these objects would iterate to complete that whole. And depending on the size of the object that they have, and maybe they need many of these, okay? For the start, maybe they need erasers so they can lay one eraser after the other, and then they'll start understanding that they can iterate. They can just move that object along the way rather than having all the objects that are needed. And we can have a variety of objects that they could check and see, and it also gives them the idea of the size of that unit. If, for example, this eraser is a larger size unit than this dice, so of course you would need less of these and more of these, which starts giving them the idea of the comparison that the more, okay, if I need, say, 10 of these, I might need 12 of these. Well, 1/12 is smaller in size than 1/10, or whatever it is might be. For students to understand and gain that conceptual understanding of fractions, we want them, it starts with that partitioning of equal size, those iterations, but then it leads into that kind of a measurement model, because that's what iterations usually are. You can have an iteration of a millimeter, of a centimeter, of a decimeter, of a meter, and so on. But this has really shown me, I was just impressed with where students in grade 3 could develop their understanding of unit fractions through this French fry model that was talked about within this article. So this is how I took it. I usually read articles and then I take it into what I know is my understanding, and of course I may make some twists and some modifications of what they're telling me. But I just cut up this paper, just strips of paper, and we talked about this as a whole, okay? And what I had them do to start, and in this article I'm just going to backtrack, and yes, I know that I've had people talk about, well, folding is a really great way for students to understand unit fractions as well, but how do you fold? It's easy to fold in half and then to half that and to half that, but how do you start folding into sevenths and 13ths? That's really hard for little guys to be able to do that. So this is where using these objects or the finger iterations are a great way. And you can start by show me half, and they can fold half. But then, in this article it says that the teacher said, well, fold it in half, and what is each part? And the student was able to say half. But then she said, fold the first half into half, and how many parts? And this is where the student said to her, well, 1/3. Well, these aren't of equal parts. So that's where those misconceptions are. So we want students not to fold. We want students to actually use their fingers, okay? The finger iterations. And I just started with my students, is to be able to show me fifths, okay? So they know that this is, okay, we have 0 and 5. You're actually starting with that magnitude of whole number, okay? And you want them to share this, say that this is the French fry or this is a whole, and they're sharing it with 5 people. And you could start with halves and then thirds and fourths, but in grade 3 I started mine with fifths. So what I did is they had to use their fingers, and they just had to make sure that they kept track, okay? And of course sometimes they lose the size and those kinds of things, but they have to be patient and they need to keep trying. So 2, 3, 4, 5. And what I would be doing is I would be going around saying, well, is that too short or is that too long? And they would say, well, that's too short. So then what has to happen with the size of the iteration? Does it have to grow smaller or does it have to grow bigger? And some students don't know that right away. They just continually go by trial and error and all kinds of things, and it develops. So okay, so I need to go a little bit larger. So 1, 2, 3, 4, 5. It's still a little bit too short, so I'm going to have that iteration grow larger in size again. And remember, you don't want them to overlap. That's important, so they're keeping track, and they're not writing or anything down. They're not marking it up with their pencil. 2, 3, 4, 5. Oh, I still need to go a little bit bigger. Okay, so I'm going to go quite a bit bigger here. So 1, 2, 3, 4, 5. I went over. So that means my iteration needs to be a little bit smaller, but I don't want to tell them there. I want them to figure that out. Okay, 1, 2, 3, 4, 5. Got it. So I don't want them, they need to try to hang on to that. And once they have that copy, they can take their pencil and put that in. Because if they put that mark, then they lose track, and always they will go back, because that's that iteration. It's going to copy itself. Okay? So if they lose track, they know, and they need to move. Okay, and check again. Okay, and if they're not exactly perfect, that's okay the first time. And I give so many minutes, and there's, out of my 27 kids last year, within 15-20 minutes, some of them still didn't get that. There was productive struggle, but we went again and again and again and again and again. And it's amazing how fast that they catch on. So what I have them do then is, okay, divide those, then make those lines a little bit bigger, okay? And they know that this is 1 part, this is 2, 3, this is 4, and of course this is 5. So this is not the iteration. This is the iteration. It's the space between, and we need to be really careful that they're not counting these tick marks, that this is the iteration. So 1, 2, 3, 4, 5. Okay, so then that's their magnitude of whole number. So I would say, okay, well, this whole, we have just shared it into fifths. So this is 1/5, 2/5. We don't want to say 1 out of 5, 2 out of 5. That again causes a misconception. It's 1/5, 2/5, 3/5, 4/5, and 5/5. And of course, if I go back here, this is 0/5. So students know that 1/5 is 1/5. 2/5 is 2 1/5. 3/5 is 3 1/5. 4/5 is 4 1/5. And 5 is 5 1/5. And this is really important for them to know, because we want students to be able to decompose fractional numbers just like they decompose whole numbers, because that's going to be important to them when they start adding and subtracting, multiplying and dividing fractions. So this is just how we want to start with our students. And again, go again with the next lesson and keep these and say, okay, well, you shared, this was a French fry or whatever it is, or a chocolate bar, or whatever. It doesn't have to be a French fry. You want to share it with 6 people, okay? So when they have this to compare to, and that's really important, do you think that 1/6, or each 1/6 is going to be smaller in size than the 1/5 or larger in size? And again, that would come. Well, it would have to be smaller in size, okay? So they would have to, again, start thinking about that, okay? So 1, 2, 3, 4, 5, 6. A little bit too small. So I'm going to go here. So 1, 2, 3, 4. Whoop, I just lost my track. Okay, so if I want to think about that, so 1, 2, 3, 4, 5, 6. A little bit over. So I'm going to come back. Okay, 1, 2, 3, 4, 5, 6. So it could be a little bit. You just, and they have to keep playing. 1, 2, 3, 4, 5, 6. No, it's still a little bit bigger. 1, 2, 3, 4, 5, 6. Yay! Okay, so again, I'm just going to mark it. 2, remember, that's the iteration, the space between 3, 4, 5, and 6. And again, I want to do this. Okay, so I've got 1, 2, 3, 4, 5, 6. And now this becomes 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. And you can do this over several days, and they could do fourths and thirds, and they can compare. And you can see that this is where kids too, even with comparison, and you write down, okay, 1/5 and 1/6, then you want them to compare. Students would tell you that the 1/5 is less than 1/6, because all they're doing is they're looking at those numbers in comparison, and they're not thinking about the size of the unit. And actually, as the denominator becomes greater, the iteration becomes smaller. So 1/6 is actually less than 1/5. And 1/4, okay, because 1/4, that iteration would have to be bigger, because you need only 4 spaces or 4 iterations rather than 5. So 1/4 would be greater than 1/5. So this starts helping kids see that comparison and that idea of those unit fractions. Then when you get into something like 4/5, say, plus 2/10, students would know that this is actually what they can actually think about. That is, this is actually, okay, 1/10, that's actually 1/10, and that's, you'd have 10. This is actually 1/5, 1/5, 1/5, and 1/5. But if we look at that in comparison, students would then have to know, well, okay, well, how does that compare? If I've got a strip of fifths, say 1, 2, 3, whoa, I need this to be 1, 2, 3, 4. Well, you'll get that idea there. I'll just move this in here. And I need the same strip, okay? But I need tenths. Okay, so think about this as your fifths, right? So 1, 2, 3, okay, but you got 2/10, so you got 1, 2, so 2/10, so this is the 1/10, and the one, well, no, you got 2/10 there. So we've got 4/5 shaded in, but how many tenths would that be? So we've got 2, 4, 6, 8. That would be 8/10. So if we had 8/10, that 4/5 would actually be 8/10. So if you have another 2/10, then what would you have? So those are the kinds of things we want students to understand and be able to do, because 4/5 is equivalent to 2/10. So then that's actually 10/10. So that's actually a whole when you do that adding. And this is where our students don't understand these kinds of things. So this is just a little bit on helping them build that conceptual understanding of fractions. And there is going to be more to come. This is a freebie for you in starting with that understanding of fractions, and there will be more. There were a pre-recorded webinar in showing you some further work that you would be able to actually purchase and continue on with your class. But I'm hoping this is helpful, and I'm hoping that we can really start helping our students as young as grade 2 and 3, having that conceptual understanding of unit fractions and that deep understanding, so when they're moving into later elementary years, that deep understanding of fractions is not going to throw them off when they're actually having to add, subtract, multiply, and divide fractions with both like and unlike denominators. And that's where I'm going to leave you at. And if you have any questions, please email me through my website at www.mathforsuccess.org. Or even give me a call at 403-556-3678. Thanks for your time.